Okay, folks, time for another one of those little basic concept videos. Today we're going to talk about pH buffers. Now, I know that you guys can see, you probably already know you can buy chemicals. Oh, that's a buffer. I want you to know what buffers actually are. That's what's important. A buffer is a thing that tries to keep the pH constant, tries to prevent it from changing. Now, as a quick reminder, since we use the pH word, might as well. If you have a low pH, it is very acid. The solution is full of hydrogen ions. It's very acidic. If you have a high pH, it is full of hydroxide ions. It is very, very acidic. We've talked about that before, but acid means it's full of hydrogen ions, almost no hydroxide. Neutral means you have equal hydrogens and hydroxides. Base means you have lots of hydroxides, almost no hydrogens. And a buffer is like these here is going to try to keep those constant. And you might say, how? I mean, that's like crazy. How could you do that? Well, one example of that would be the protein albumin that's in your blood plasma. It's part of what gives the straw color to your blood. Now, we haven't been doing this experiment here, but at a school I was at before, we used to do an experiment to show blood buffering in albumin. We would take a test tube of blood plasma and a test tube of water. And the plasma, it's a little straw colored, but they're pretty similar. I mean, they're light colored and all. We take test tube albumin, test tube of water, and we put a drop of acid into both. We test the pH, and we put a drop of acid into both, and we test it again. And right away, if you put a drop of acid in the water pH drops. Now the albumin, nothing happens. You put a drop of acid in again. Hydrochloric acid is what we're using. The albumin stays the same, and the water drops again. And you do it with another drop, and the water goes down, and the pH goes down. And then you do it maybe the fourth or fifth time. Eventually, the albumin's coming down too. But what's been happening? Albumin is one of its jobs. It has a lot of jobs, osmolarity and stuff. One of its jobs is buffering blood pH. And so here is a drawing to make that clear, make it make sense. We have albumin, and if we get into a condition where the blood's getting too acidic, acidemia, or acidemia is how they're up, but blood's getting too acidic. We have too much hydrogen floating around in the blood. The albumin will start absorbing, grabbing onto, taking out of the solution the hydrogens. And then the pH can come back up close to where you want it. By the way, where you want it in blood, you want your pH to be around 7.35 to 7.45. That's the normal range for human blood pH. But if the blood is getting acidic, albumin is going to take some of the hydrogen out of that, so it will raise the pH back up to normal. Now, the same thing, a buffer tries to fight change in both directions. So if the blood gets a little too alkaline, a little too basic, then we have a lot of hydroxides and very little acid, very little hydrogen ion. And we want to move back to the neutral. So what are you going to do in that case? You're going to release hydrogens into the solution to try to get it equal. So let's go back to our picture right here. And in this case, if it gets too basic, albumin will dump off most of its hydrogens, and they will be in the solution, bringing it closer to the neutral where you want to be, or closer to the 7.35 actually. What I should have said is it will bring it back to the normal for blood. So you understand that buffers try to keep it going too high, too low, that they can absorb or release hydrogens. There are other forms of buffers too. It's not just like the protein albumin. You've got lots of buffers in your body. Here, the bicarbonate buffering system, this is carbonic acid, and you can see that carbonic acid breaks down into a bicarbonate, that's a base, and a hydrogen. And because this reaction is reversible, because it goes in both ways, if you have too much of one, you can absorb the other. You got too much bicarbonate, it can bind to hydrogens to turn to carbonic acid. The stuff's gone away. And you can go the opposite direction. So we have more than one type of buffer, and both of them, I shouldn't say both, we have 4 different types of buffers in the human body, but all of them are working to avoid having big changes in the ratios of hydrogen to hydroxide, and trying to get back to what is normal for human blood, which is 7.35 to 7.45. I hope that makes sense to you guys.